find the B bar so that tension in the string will be 0. This is a path, circular path. Now, what are the forces that will be acting? So here QVB, avoid electrostatic interaction. I think every problem you're supposed to no electrostatic interaction, no electric forces. I'm making clear. Even in question they'll mention avoid or neglect effect of electrostatic forces here. What should be the forces that will be acting here? No? So what should be the magnetic field? So here let's assume that tension in the string should be 0 is telling. So then all power required centripetal force, the QVB. If you want to assume tension, so what is the magnetic field? He himself is asking tension must be 0 for that. Tension in the string must be 0. So therefore, shall we assume QVB equal to mv square by L? What should be the magnetic field equal to mv by QL? So this is the magnetic field strength. Now what I do, I'm going to project with the same speed. I'm going to decrease the magnetic field. So in the diagram 1, so what is the thing? Now the field strength is decreased to B by 2. Find the tension in the string. He's putting a condition. Let the field strength, let it be decreased to B by 2. Same speed they are projected as usual. You can look at this one. Then what are the forces that will be acting? The magnetic Lorentz force QVB by 2. Then tension so what are the equations of motion will be? T plus QVB by 2 is equal to mv square by L. Substitute the value of B there, what we have from earlier equation, substitute, you're going to get the required thing. Okay, some questions, connected strings with friction, anything. It's a very, what I said, it's a very generalized topic. Only that Lorentz force F equal to QVB is what you must know. The remaining rest all everything, they can bring any of the basic situation. So QV by 2, B is what? MV by QL. Tension is equal to mv square by 2L. Let's come for some ampere force, some few applications. Read question number 38.